So we don't have to add like a billion.
Very good. Yep, very good. Both of those are what I'm looking for here. The reason we use scientific notation is that it gives us a lot of flexibility and it allows us to express really large and really small numbers, right? That's what scientific notation does. It allows us to express really large and really small numbers with more flexibility, with a little bit more ease, without having, like we said, 6 zeros on the end of one side of our measurement or not. But it allows us to be able to do that, okay? Okay, scientific notation follows a general formula of m times 10 to the n. M times 10 to the n. And the rule is that m, or this number right here, has to be between 1 and 10. It has to be between 1 and 10. Sometimes we forget that rule, and we see scientific notation written like this, 0.32 times 10 to the first. Is that a valid scientific notation? No, because this number is not between 1 and 10, right? If I wanted this to be the right number, I would go 3.2 times 10 to the whatever exponent I need, right? But it has to be between 1 and 10, okay? For numbers that we're trying to express that are greater than 10, if we're trying to express a number that's greater than 10, our exponent is going to be positive. And if we are trying to express numbers that are less than 1, our exponent will be negative. Okay? If we're trying to express a number greater than 10, our exponent is going to be positive. If we're trying to express a small number that's less than 1, our exponent will be negative. I don't like to try to teach, if we move the decimal left, it's this, and if we move the decimal right, it's this. I don't like that because sometimes I start in different places. And so I just want to give the kind of general consensus that if our number that we're trying to express is greater than 10, we have a positive exponent. And if it's less than 1, we have a negative exponent. So let's just try some of these examples that are listed here. Okay, I think those are printed for you on the next slide. Let's try some examples. Okay, I want to put this number into scientific notation. Right now, is this a really large number or a really small number? It's a really large number. So would we expect the exponent we're going to use to be positive or negative? Positive, right? Because our number we're trying to express is greater than 10. And so what we do, the way we look at this is we find out where our original decimal place is, right? My original decimal place is at the end of all these numbers. Don't we agree? Original decimal place is there. And now I need to get my decimal place somewhere that gets me between 1 and 10. So where should I move my decimal place to? Between the 5 and the 3. My decimal place needs to go there so that it's 5.313, whatever. I keep going. So now all I have to do is count how many decimal places did I have to move. How many places did I move that decimal? 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 places. So when I come set up my thing, it's going to be times 10 to the 8. But now I've got to figure what number goes in front of there. Right? What do we think here? 5.31. And we can just stop it there. Right? If I want it to be really exact, I could say this. 5.31312 times 10 to the 8th. Right? These both represent the same number, but this one is much more exact, right? This one gives me much more exact. But if I were going to expand this number out, it would just be this: 531000000. 1, 2, 3, 4, 5, 6, 7. Right? So by doing that, by rounding it to 5.31, I'm losing some of the exactness of that number. Does that kind of make sense? When we put numbers into scientific notation, we lose some of the precision of our measurement unless we can write it all the way out like this. Okay, we don't have to always do that. I'm okay if we round some things off, and I'll give you some rules to figure out where we round that stuff. But for right now, we just have to understand if we do this, right, this number and this number are still representing around the same numerical value, but this one is much less exact than this one. Okay? So it might tell you, put this number into scientific notation with 2 decimal places. And that's what this would be, 2 decimal places. Because you know what I mean when I say decimal places? Digits after the decimal point. Are we on the same page with that? Okay. So let's try the next one here. Let's say that I want this next one in scientific notation, let's say with 2 decimal places. I want this number in scientific notation with 2 decimal places. So let's locate my original decimal point right there. And where do I need to move it between? Yeah, there we go, right there, right? And so all I have to do is count. 1, 2, 3, 4. I moved it 5 places. So I'm going to set it up to be 3 point what? 4, 3 times 10 to the negative, I think 5. 1, 2, 3, 4, 5. Yeah, negative 5. So that number is in scientific notation with 2 decimal places. Is this something that seems kind of familiar to us? Okay. Now the next one, I want you to put this next one into scientific notation with only 1 decimal place. With only 1 decimal place. So where's my original? Where's my original decimal at?
At the end.
At the end. And it needs to go between the 4 and the 0. Right? It needs to go there. So that counts as 1, 2, 3, 4 spots. So am I going to say 4.00 times 10 to the 4? No, because what was my instruction? To put it into scientific notation with what? With only 1 decimal place. So that means I don't get to have that 0 right there. It just becomes 4.0 times 10 to the 4.
Do you have 2.0?
Yep. And I'll talk about why that is. It has to do with something called significant figures. It kind of gives us another level of exactness to our measurement. Okay? All right, very good. Tell me, what questions do we have so far? I want you to put this last one into scientific notation with 1 decimal place. So this one I want scientific notation with 1 decimal place. I want you to put this number into scientific notation with 2 decimal places. Into scientific notation with 2 decimal places. Put that number into scientific notation with 2 decimal places. Did we come up with at least times 10 to the negative 5th?
Yeah.
Now I want you to tell me what are the 2 decimal places that are going to go there?
7.8.
4.78. How many of you would agree? How many of you disagree? Do you know why?
Because the other 8's bigger than 5.
Yeah, it's going to round that up to a 7, 9. Right, so let me show you why this is, okay? I want to show you why this matters. Okay, because if I look at my number, if I look at my original number, right? Here's the original number that we had to express. And here is where I think it needs to be rounded to. Here's why, okay? Let me kind of move this up out of the way here. This number, 4.79 times 10 to the negative 5th, is the same as this, 0.0000479. But if I had 78 times 10 to the negative 5th, my number would be this, 0.0000478. Now, if I look at my original number, is it closer to the top or closer to the bottom? It's closer to the top. Look, because this 88 is closer to 9, right? 88 is closer to 9, then 88 is closer to 80. You know what I'm saying? Mm-hmm. Okay, if you even think about putting a 0 on the end, which we don't need to, but if you think about if there's a 0 here, look, is 88 closer to 80 or is it closer to 90? Right, it's closer to 90. And so that causes that number to get rounded up. So this number is closer to our actual value than 4.78. So our final answer there should have been 4.79 times 10 to the negative 5th. And I wanted you to have to look at that next number to round it.
Does that only ever do like the 2 decimal places?
Yeah, so even if it would ask you, if let's say that I'd asked you to do this number with 1 decimal place, you would go 4.8 times 10 to the negative 5th. Right? Okay, so if I'm looking at 1 decimal place, I'm looking to be here. I've got to look at the next number and see, does it round up or does it round down? And 5 or above rounds up, 4 or below rounds, or stays the same. Okay, do we feel comfortable with that? All right, let's move into now taking numbers out of scientific notation. This is simple. This is just moving the decimal place and trying to give the number that we're trying to express, okay? So this first one says 4.21 times 10 to the positive 3. So is the number we're trying to express big or small? Big. Okay, and so to do that, I'm going to say it's 4.21 times 10 to the third. So all I'm going to do here is I'm going to go 4, 2, 1. Here's my decimal place. I'm going to move it 3 to make my number bigger. 4, 2, 1, 0. Right, there's my number. I want to move the decimal place so that my number becomes bigger. Right, my number becomes larger. So 4,210. What about this second one here? Am I going to move my decimal place so that my number gets bigger or smaller? Smaller. And so I'm going to start with 3.39 and I'm going to move it smaller 5 places. 1, 2, 3, 4. So it becomes 0.0000339. Okay, negative decimal place means I want a small number. Negative exponent means I want a smaller number. Positive exponent means I want a bigger number. Why don't you try the last two on your own? Try the last two on your own here.